Find a 3 by 3 magic square using the numbers 4, 7, 10, 11, 12, 15, 18, 20, 23, and 26. And we're going to fill in the magic square that's been given to us. So how do I go about doing that? Well, the first thing I need to do is understand that I'm going to use all 9 numbers right here in the magic square. And that the sum of this row here and the sum of this row here and the sum of the third row is going to be some value for each one of these. But they're all going to be the exact same value because that's the idea behind the magic square. So that means that if I were to find the fixed sum of each one of the rows, diagonals, or columns, I should be able to calculate where these numbers go. So we'll start by first adding all the numbers together that I'm given, and then I'm going to divide by 3. So we start with 4 plus 7 plus 10 plus 12 plus 15 plus 18 plus 20 plus 23 plus 26. And that will be equal to 135. Because remember, I'm using all 9 digits in the sum. So 135 divided by the number of rows, which will be 3, will be equal to 45. That means that this is the fixed sum of each row also each column and each diagonal. Now, there are 3 rows, there are 3 columns, and there are 2 diagonals. If we look at the center value right here, you'll notice that that's contained in 1 column. It's also contained in 1 row. It's also contained in 1 and 2 diagonals. So that means that the center number is going to exist in 4 separate sums. And we also know that 7 right here will be in this diagonal sum. We also note that 10 will be in this column sum. So what we're going to do is we're going to look at all the numbers 4, 7, 10, 12, 15, 18, 20, 23, and 26, and we're going to go ahead and group them so that they add up to 45. So now what I want to do is I want to create as many possible ways of finding the sum of 45 using 3 different numbers from the given group of numbers. For example, I know that 7 is going to be one of the numbers in one of the sums, and I also note that 7 plus 18 plus 20 will be equal to 45. But I need to determine, is that going to be the only possibility? Will 7 exist in more than one grouping? And so now what I'm going to do is I'm going to determine as many of these as I possibly can. Now, I know that you're wondering, how am I going to do this? Well, we'll go ahead and we'll move this one out of the way for the moment, and we're going to go ahead and we're going to start with the number 4. Let's consider 4. If we take the total sum of 45 and we subtract 4 from that, we'll be left with 41. Now what I need to do is find 2 numbers that add together from this grouping that's equal to 41. Well, I could start by simply taking 41 and subtracting 7 and seeing if I get another number that is in this list. So 41 minus 7 is equal to 34. And we see that 34 does not occur in here, so this is not going to be part of my sum. So we know that 7 is not going to be part of the sum 4 plus. So we'll try 10. Let's take 41 and we'll subtract 10 from that, and that leaves 31. That doesn't work either because 31 does not exist in my list. So let's try 12. 41 minus 12, and that will be equal to 29. That's not going to work because 29 does not exist in my list. So we'll try 41 minus 15, and we'll see what that gives us to see if that has a number that's in our list, and that would be 26. And once again, that number exists right here. So I know that 4 plus 15 plus 26 will be equal to 45. So are there any other possible combinations of 4 plus? Well, let's look at 41 minus 18 and see what we get for a number. So 41 minus 18 is equal to 23. And guess what? That exists. I have 18 and I have 23. So 4 plus 18 plus 23 is also 45. Now there's no other possibilities that include 4 in the triple, so now I'll move on to 7. Now we've already got one of them, but we're going to go ahead and continue to see if there are any others. And it makes sense that there will be, because if you notice, 7 exists in this corner, so it will be part of this row, part of this column, and part of this diagonal. That means 7 will exist in 3 possible triples. So using the same concept, we'll take 45, we'll go ahead and subtract that, or subtract 7 from it to get the balance of what we need to find, and that's going to be 38. So we already know that if we take 38 and subtract 18, we get 20, and that will add up to 45. But let's see what else happens. Okay, we know that if we try 4, it's not going to work because we've already done the triples for 4. So let's try 10. So let's 38 minus 10. That leaves me with 28. 28 doesn't exist in this group, so I don't need it. So then we'll try 12. So we'll take 38 and we'll subtract 12, and that will give us 26. 26 does exist, so that means we have 12, 26, and 7. Now we know there has to be at least one more, so now we'll try 15, and so we'll take 38 and we'll subtract 15 from that, and we note that we will get 23. So that works. So 15 and 23 and 7 is another triple that adds up to 45. And since we already have 18 and 20, I don't need to do any more. So now we're going to go to the next number, 10. So we already know that 4 and 7 are not going to be included in this grouping for 10 because 10 wasn't found in our triples that included 4 and 7. So we'll take the total, 45. We subtract 10, and that leaves 35. So now we're going to go to the next higher number, which is 12. 35 minus 12, which will give us 23, and we have another triple. So 10, 12, and 23. And that's equal to 45. So now we'll move to 15, and we'll try 35 minus 15, and that yields 20. Well, that's another triple. And so we have 10 plus 15 plus 20 is equal to 45. Now, let's just try 18 to see if we get 26. 35 minus 18 will give us 17, and we know that that one doesn't work. So now we're looking at these different possibilities. And it makes sense that 10 will only have two triples that it is part of, because if we scroll back up and look at the magic square, we'll see that 10 is in this column and this row. So it's only part of two sums, I should say. Alright, so let's move on to the next number in the sequence. So the next number in the sequence is 12, and if we look at that very carefully, we note that 12 already exists in two of our sums, which is going to be this one right here and this one right here. So I'm just going to write those out. I'll have 12 plus 7 plus 26 is equal to 45. And then I'll have 12 plus 10 plus 23 is equal to 45. And there's a reason I'm going to write all of these out, and I'll show you that in a moment once we have all the possibilities. But we also need to make sure, are there any other possibilities for 12? Well, we know that 7 and 26 are taken care of. We also know that 10 and 23 are taken care of, which leaves us with our next number of 15. So if we have 45 minus 12, that's going to give us 33. So we'll take that number and we'll subtract 15. So 33 minus 15 is going to yield 18, which is a number that exists in the grouping. So that means that I will have 12 plus 15 plus 18, and that's going to be equal to 45. And there shouldn't be any other possibilities, because all we're left with is 4 and 20, which is 24 plus 12 gives us 36 and not 45, so that won't work for us. Okay, so the next number in the sequence is 15, and I know that 15 is contained here. It's also contained right here. It's contained right here, and it's contained right here. So let's just write those down in order with 15 plus 4 plus 26, that's equal to 45. Then we have 15 plus 7 plus 23, that's equal to 45. We also have 15 plus 10 plus 20, that's equal to 45. And then we have 15 plus 12 plus 18, and that's equal to 45. And I know that there's not going to be any more, because at the most I can have is 4 triples that have the same number, because that means that's going to go in this center square. But we could go ahead and look through it. Let's see, 15 and 4 and 26. 15, 7, and 23, 15, 10, and 20, and then 15, 12, and 18. We've actually used all the numbers, and I don't need to continue with 15. All right, the next number is 18. And let's see, do we have any sums with 18? 1, 2, 3, and if we notice, this is the exact same one as this one, so I can't recount that one. So that means that we have 18 plus 4 plus 23 is equal to 45. We also have 18 plus 7 plus 20 is equal to 45. And then we have 15 plus 18, or let's make it 15 plus 12 plus 18, and that's equal to 45. And it makes sense that there wouldn't be any other triples, because this right here has already taken care of the center square. Now it should make sense to you that there shouldn't be any more unique triples, because now we're looking at numbers that are greater than 15. We know that 15 is going to be in the center, so at most we'll have 3 unique triples or 2 unique triples, but more than likely they've already occurred. So let's look at the next number in our sequence, which is 20. Let's see if we find 20 anywhere else. Well, it's right here, and then again right here. And that would be 3. And we note that the 18, 7, and 20 already occurred right here, so I don't need to rewrite it. But let's go ahead and write that with 18 in the lead, 18 plus 7 plus 20. And I don't need to write the equals 45 anymore. And this would be, and I apologize, what I meant to say was we'll write the 20 in the lead position, so 20 plus 7 plus 18, and then we'll write 20 plus 10 plus 15, and then we'll write 20 plus 10 plus 15 already occurs, and I don't need to rewrite that anymore. And so you'll see that it's an easy way to check your triples. So the next one that we're going to do will be 23. And we'll look through all of these for 23s, which is going to be right here, right here, right here, and then again right here. And we need to make sure, do we have any duplicates in that group? So let's go ahead and look at this one. This one's going to be 23 plus 4 plus 18. This next one will be 23 plus 7 plus 15. And it makes sense that since 15's in this, we're not going to have to rewrite it again when we get to here. This one will be 12 plus 10 plus 23, and this one is 10 plus 12 plus 23. So they're the same, so I only need to write it once. And then do I have any others? And it looks like those are the only 3 possibilities. So now we move on to the final number, 26. And if we go ahead and look at this, 26 occurs right here. It occurs again right here. It occurs here, but we'll notice 12 plus 7 plus 26 is the same as this one, so I won't need to write that twice. And then we look for another 26, and we note that 26 occurs here, but it's the same as this one, so I don't need to write that twice. And 26 does not occur anywhere else. So now I know that I have 26 plus 4 plus 15, and then 26 plus 7 plus 12. Now, the reason that we've written them all out like this is we're going to make a table. And we're going to write out the numbers that are in our sequence, which is going to be 4, 7. And now we want to know how many times does 4 occur uniquely. Well, we can do that by looking right here. 1, 2 times. So we'll write that as 2. What about 7? Well, that's 3 times. What about 10? That's 2 times. What about 12? That's 3 times. What about 15? Well, that's going to be 4 times. 18 occurs 3 times. 20 occurs twice. 23 occurs 3 times. And then 26 occurs twice. Now, I know this seems like a lot of work to get to this point, but now we can actually begin to fill in the magic square. Alright, so let's begin by filling in the center square, which we know has to be 15. Because 15 occurs in 4 of the sums, which means 1 row, 1 column, and both diagonals. We also note that since there's a 7 here, we can go ahead and we can say, okay, 7 plus 15 plus 23 we'll put 23 right here. That means that 7, 15, and 23 are now taken out of the grouping, and I don't have to put them anywhere else. But I am still going to use the 15 and the 23 and the 7 because they occur in more than one triple. I also note that since there's a 10 right here and there's a 15 right here, I will look for the 10, the 15, and whatever number is missing right here. So I have 10, 15, and 20 right here. So I can put 20. So I know that 20 is now dealt with. You'll notice that I can also cross out all of these other replications of these triples. 7, 15, and 23 will occur here and also here. It's all the same. They're gone. I don't have to deal with them anymore. Now, I notice that I have a 7 and a 20 here. Well, which triple contains a 7 and a 20? Well, that would be this one. That means I can put 18 right here, and now 18 is gone. And wherever 7, 18, and 20 occurred in my replications, I can also get rid of them. Now, what am I missing? Well, I know that I need this piece here, and it's going to be 18 and 23 added together. So what piece is missing? That would be a 4. So I put in the 4 right here, which means I look for all the 4, 18, and 23 triples. And let's see, 4, 18, and 23 triples. That's right there. And you'll notice that there's only going to be those 3. They're gone. Now, remembering that this 10 means that this 10 is gone, and I'm left with 12 and 26. So we have 4 plus 15. What value is that going to be? We're going to look for 4, 15, and 26. So we'll put 26 right here. And make sure that we get rid of any other triples that occur within this. That's a 4, a 15, and a 26, which would be this one right here. And I don't see there. Okay. Now, what's the remaining number? It has to be 12. So we put 12 in there. And make sure that we've got all of those added up. Okay. This is going to be 12, 10, and 23. So there's a 12, 10, and 23. Do I have another 12, 10, and 23 somewhere? And that would be right here. Now, I also need to look at this one right here, which is 7, 26, and 12. 12's gone. I need to make sure there's a 7, 12, and 26. Are there any other 7, 12s, and 26? Right there. Now, I want to make sure that I've got all the triples. And this is a 12, 15, and 18. Well, where's 12, 15, and 18? That's this diagonal right here, which I didn't have to worry about, but now it's gone. And then, are there anything else left that I can possibly eliminate? Well, remember that we had 20, 15, and 10. That's gone. That's gone. And 18, 12, and 15. That was this diagonal here. I've taken care of all the triples. I've got all the numbers. Is this a over, or I should say lengthy explanation? Yes, it is. Is there an easier way of doing it? Yes, there is. And it's simply by looking at the squares and determining the triples and trying. You can use a guess, check, and revise. There's a number of different ways to look at this. But this right here is going to be the way to eliminate or make sure that you have used logic to find all of the components to the square.